So we're going to do product rule today, which honestly is some problems we're going to have to use product rule. For some others, product rule is not the most helpful right now. When we learn chain rule also, it will be more helpful, and I'll explain that sort of whenever we get to it. So the product rule. So this is a rule that we use for taking derivatives. So if I have something like y equals x squared times cosine x, it seems as if you should be able to do like the derivative of cosine of x squared is 2x, and the derivative of cosine is negative sine, and then you just slap them together, right? But you cannot. So when we take the derivative of two things that are multiplied together, so we've got f of x times g of x, we have to do f of x times g prime of x plus g of x times f prime of x. Okay? So this is what that is going to look like here. The derivative of y, you can call it dy dx, you can call it y prime, whichever one you prefer. To take the derivative here, like we could let our x squared be our f of x and our cosine x be our g of x. So the rule says we've got to take just f of x. We don't do anything to it. It's just f of x. That is just going to be x squared. And we are going to multiply it by g prime of x. So g prime of x, we need to take the derivative of the g part of the second part. What's the derivative of cosine? Negative sine x. Okay. Then we will have a plus sign. And then it tells us to do g of x. So g of x is just the second part. Don't change anything about it. It's just cosine x. And then we multiply that by f prime of x. So the derivative of the first part, which is going to be, in this case, 2x there. So, whenever you do this, just to make sure everybody knows where this comes from, this part right here was your f. This part right here was your f prime, the derivative of the x squared, right? This part right here is your g prime. This part right here is your g. Okay. Not real, like, you can do the, like in this, because it's addition, if you do g times f prime plus f times g prime, then you'll still get the same answer. You do need to make sure, like, that f has to go with g prime. F can't go with g, or f can't go with f prime. So you have to have the two pieces that are together must be together, but if you switch their order, it will be fine for that. And then most, like for a problem like this, there's not much you can do for that. You will probably see it cleaned up a little bit where you have like negative x squared sine x plus, we usually write the 2x out front, cosine x. You'll probably see it look something more like that. But there's not much you can do to combine those. Okay, you must do this whenever you have two things that are multiplied together. Okay, so let's go look at another one. Okay, now this particular problem, there are two ways that you could solve the problem. You can use the product rule, or you don't have to use the product rule at all. So let's just real quick, if I want to do this without product rule, then what I need to do is I need to multiply it together first, right? Before I take the derivative, I can't take the derivative like it is unless I use the product rule. So I would multiply it together. I would get 15x plus 12x squared minus 10x squared minus 8x to the third. So I'm just, distributing there. 3 times 5, 3x times 4x, negative 2x squared. Gets distributed as well. I could combine like terms. Notice I still have my derivative notation here. And so I've got 15x plus 2x squared minus 8x to the third, like this. So if you expand that, then you just need to use the power rule to take the derivative, right? The shortcut that we learned a couple days ago, you're just using that power rule. So it's going to be 15 plus 4x minus 24x squared would be your answer. It means that you're taking the derivative with respect to x. Like, we'll take the derivative with respect to other variables at other points. As far as why they decided, like, for it to look exactly like that, I'm not sure. But why it's got the dx. Like, it's possible for us to do, like, d dt or d, and we'll see that later on. Okay. All right. Now, let's go over here. This is an option, perfectly valid option, possibly easier, possibly. But let's also look at how we could use product rule for this. So if we use product rule, we're going to say maybe like this first part is my f of x, and my second part is my g of x. So our answer is going to look like this. We'll have f, which is 3x minus 2x squared, times the derivative of g of x. What would the derivative of 5 plus 4x be? It's just 4. Plus g of x, so 5 plus 4x, times the derivative of 3x minus 2x squared, which is going to be 3 minus 4x. Okay, you would need to simplify here, so you would need to distribute this 4. You will get 12x minus 8x squared. Over here, you've got to like FOIL this together, so you got 15 minus 20x plus 12x minus 16x squared. And then if we put everything together, negative 8x squared and negative 16x squared would give us negative 24x squared. We got a 12x, a negative 20x, and another 12x is going to give me a positive 4x, and then you got the plus 15 on the end. Notice that that is the same answer that you get the other method. On these, I would almost argue that it's easier to do it the first way, that I did it without the product rule. There are some, when we learn chain rule, there's going to be some where we pretty much have to do it this way, but it would not necessarily be this problem. Now, example 1, where we had that cosine, you cannot get around it because you can't simplify that to make it a product rule problem, or make it not a product rule problem. But on ones like this, you have options. You can do either or. Okay, questions? All right, let's look at example 3. No, they're not. This one has a piece that needs the product rule and a piece that does not need the product rule. Because when I have a minus sign in between these two right here, that means I'm going to take the derivative of those two things separately. 2 sine x does not need a product rule, because 2 is just a coefficient, right? What about this? This has to be product rule because this first part right here has an x with it. So 3 is not just a coefficient here. 3x is an expression that involves a variable. So this part is going to be your f, and this part is going to be your g, and then you're just going to take the derivative of this other stuff separately at the end. Okay? So when we take the derivative of this one, we're going to have f, which is 3x, times g prime. The derivative of sine would be cosine of x, plus, then we got g of x, which is sine x, times the derivative of f prime. What is that? Nope. It's 3. So derivative of 3x would be 3. Right? Okay, so like that is our product rule part. We still over here have to take the derivative of negative 2 sine x. And what is the derivative of negative 2 sine x? Negative 2 cosine x. That does not have to have a product rule because it's just a coefficient of 2 for that. There. So let's make sure everybody knows where everything comes from. This was your f. This over here was your f prime, right? It's your derivative of that. This part right here is your g prime. This part right here is your g. And then you had this other piece over here that you just had to take the derivative of right there. Okay. This can't really simplify much. They'll probably clean it up a little bit. They'll probably write 3x cosine x plus 3 sine x minus 2 cosine x. Can you put the cosines together? You cannot, because this cosine has this x out here, so it can't be combined. So you would just leave it like that. Okay, questions? All right. Okay, they love on the AP exam to give you these theoretical problems where you don't have the full equation. Okay, they give us a bunch of information. F of 3 is 4, f prime of 3 is negative 2, g of x equals 3x squared times f of x. We're supposed to find g prime of 3. Okay, so our goal is to take the derivative of g and then plug in 3, right? So we're trying to take the derivative of this stuff right here. So we will have this first part right here. I would call it f of x, but the other piece is f of x, so let's call this one g and this one f right here. So we got 3x squared being multiplied by some other unknown function that we don't know. So whenever we do product rule for this, we're going to have our 3x squared. What is the derivative of f of x? It's going to be f prime of x. So we don't know what f is, but we would just call it f prime. That would denote that we're taking the derivative of f, right? Does anybody need to go get lunch? Everybody had lunch? Anybody need lunch? Because you are welcome to. I'm recording if you need to, if you want to go get lunch. Okay. That sounds like more people than really have second lunch, but maybe it's right. Cafeteria's probably got 300 people in it right now.
Well, I think it was second lunch was combined with something else. I think.
Yeah. Well, I think the problem with second lunch is that like half, like classes are going to be like half and half. Like x. Some kids have second lunch, and some kids have first lunch, but they're in the same class. So you're like left with kids that already had first lunch, and maybe they just sneak off to second lunch. I don't know. Or maybe they're mostly down here. I don't know. All right, so we got 3x squared times the derivative of f, which we're just going to have to call f prime because we don't know what f is, right? And then we'll have f of x times the derivative of our, in this case, g here. What's the derivative of our 3x squared? 6x. Okay. There's not really anything you can do to this. So you can't really combine anything. But they're asking us for g prime of 3. So if we're finding g prime of 3, we're plugging in 3 for all of the x's. So we got 3 times 3 squared times f prime of 3 plus f of 3 times 6 times 3. Right? That's what happens when we do when we evaluate a function at a value. We just replace all of the variables with that number. And so when we do that, we're going to have, let's see, that's going to be 9 times 3 will be 27 times, what is f prime of 3? It is negative 2 because they told us up here that f prime of 3 equals negative 2. So we're going to have negative 2 right there. Plus, what is f of 3? It is 4, again, because they told us up here that it equals 4. Sometimes they'll do it from a table or a graph or something as well. And then 6 times 3 is going to give us 18. And so this would be negative 54 plus, what are y'all getting? 72? Yeah, that sounds about right. And then 72 minus 54 is going to be 18. If this were free response, stop right here. You don't have to go any further than that. But a lot of times, it's multiple choice, and you need to know the number.
Do you have to plug in, like if it says f prime of 3, do you have to go ahead and plug in, or would they like?
Yeah, you cannot stop. This one, not done. This one is okay for FRQ. So these things right here must be replaced for. But if you are left with just addition, subtraction, multiplication, division, even exponents are okay, but you can't have any like functions not evaluated or anything like that left. So if you're down to just like basic arithmetic, you can leave it on FRQ. And if you don't need it for anything else, I would suggest you do that just in case you mess up for that. Okay? All right, let's look at one with a graph. All right, this is our graph of f of x and g of x, and they are asking us to find h prime of negative 1. And h equals 3 times f of x times g of x. So if I want to take the derivative of this, you have two options on what to do with that 3 right there. You're going to definitely have to use product rule. This 3 right here, you can either leave out front or you can group it with the f, whichever one you prefer to do with that. If you leave it out front, you need parentheses and it gets distributed to the whole thing. If you group it with the f, you don't have to do that. I most of the time group it with the f because that way I don't have to worry about like remembering the parentheses and distributing everything at the end. And then I've got the g right here. So we got to find h prime of x first. So we're just going to have 3f of x, and we're going to multiply that by the derivative of g of x, which I just have to call g prime of x, plus we'll have g of x times the derivative of 3f of x. And 3 is just a coefficient, so that's just going to be 3f prime of x. It is almost just the formula, right? The only difference is we got that 3 that's in there. And so for this, we're plugging in a negative 1. So you're going to have h prime of negative 1 is going to be 3 times f of 1 times g prime of, oh, I'm sorry, that should be a negative 1. Negative 1 plus g of negative 1 times 3 f prime of negative 1. Okay, I'm going to list these over to the side so we're sure we know where they come from. I need f of 1, f prime of 1, f of negative 1, f prime of negative 1, g of negative 1, and g prime of negative 1, right? So what is f of negative 1 when I look at this graph? Is 3. Right, we're just reading the y-coordinate off of that graph, right? What is f prime of negative 1? F prime is the slope of the tangent line, or in this particular case, because it's a straight line, it's just the slope of the line, right? And I believe it is negative 3, because it goes down 3 to the right 1. So when we're asked to find the derivative from a graph, you're looking at the slope of the tangent line. And in this case, it is just a straight line. If it is a curved graph, they'll draw in the tangent line if they're wanting you to do that for this problem. Okay. All right. Then we need g of negative 1. What is g of negative 1? Negative 6. What is g prime of negative 1? 2. All right, so these numbers just need to get put into our formula that we have right here. H prime of negative 1 is going to be 3 times f of negative 1 was 3. And g prime of negative 1 was 2. And then g of negative 1 was negative 6. And we got that 3 there. And then f prime of negative 1 was negative 3. On an FRQ, it would be okay to stop here, but I want to know what the answer is, so I'm going to keep going a little bit. 3 times 3 is 9. 9 times 2 is 18. Here we got negative 6 times 3. Let's do that the other way. Let's do 3 times negative 3 is negative 9. Negative 9 times negative 6 is going to be a positive 54. And if we put those two together, 72. Okay, questions? We do have time to go over an FRQ. That'll be better for me too. I won't have to make a video. All right, this is your assignment, and this is going to be your remote assignment tomorrow because we are all supposed to give you some sort of an assignment. So I am just going to make this homework your assignment because you know, y'all have done enough watching videos of how to do new stuff this week already. And quotient rule.